Now that we know what a function is, let's talk about the function notation. In the past, when we write an equation, we usually say something like y equals 3x plus 2. But now it's going to become more common for you to see this written as f of x equals 3x plus 2. And I have not shied away from using this notation in the past because I think it's good to get used to seeing it. But today we're going to talk about specifically how to use this and what it means. So this is what we call function notation. And the way you read this first part on the left is you could say f of x, or you could say f at x. Those are both perfectly valid. And one thing that people tend to get mixed up here when they first see this is they think it's f multiplied by x. They think that's what these brackets mean. It absolutely does not. This is not multiplication. Saying f of x is the same as saying y, right? It just represents your y axis. Now the reason there's an x in there is because that tells us what the variable is in the function, right? So for example, what's fun about this is if they asked you to figure out what f of 2 is equal to, all that means is you're swapping out x for 2, right? Or you're going to substitute in 2 for x. So when you write this out, you would have 3 times 2 plus 2, right? And then you could say, oh, that must be equal to 3 times 2 is 6 plus 2 is 8, right? So this function notation is really handy because we can show when we're plugging in a particular number for x, just to avoid confusion. Okay, so let's do some examples with function notation. Let's say I'm given f of x is equal to 4x minus 1, and I'm also given g of x is equal to 6x plus 2, and I'm given h of x, and I'm told that's equal to 3x minus 4. And the first part of this question is, what is h at 2? What is that equal to? Well, all you have to do is plug in 2 for x in the h of x function. So you would say 3 times 2 minus 4. 3 times 2 is 6, minus 4 is 2. So your answer would be 2. Okay, that was part A. Part B, let's say it's asking us, what is f at 1 minus g at 3? How do we do this? Well, all you do is plug in 1 for f of x, right? So 4 times 1 minus 1. And then you subtract g at 3. Well, g at x is 6x plus 2, so I'm going to put 6 times 3 plus 2. I'm just putting that in a bracket to show that I'm subtracting the whole thing because I'm supposed to subtract g at 3. So you just do it like that. And then we can simplify what we have here. 4 times 1 is 4, minus 1 is 3, minus 6 times 3 is 18, so minus 18. And then minus 2 as well, because that minus, you're obviously subtracting everything in the bracket, right? So minus 18 minus 2. And what you're going to be left with is, well, negative 18 minus 2, that's going to be minus 20, plus 3 is negative 17. Let's do another one. Let's say for part C here, they're asking you, what is f at h at x? What does this mean? It looks kind of funny, right? Well, it means we're plugging in the function h of x into the value of x for the function f of x, right? So because f here is on the outside of this, the function f of x is the general structure of what we're going to write, and then the h of x is going to go wherever we see x, right? So f of x, if we recall, f of x was 4x minus 1. So f at h of x, I'm just going to plug in h of x for x. So 4 times h of x minus 1. And we also know what h of x is, right? H of x is equal to 3x minus 4. So you plug that in for h of x. So 4 times 3x minus 4 minus 1. You could have done that all in one step, but it's good to show, right, one step at a time. You would then expand this. So 4 times 3x is 12x. 4 times negative 4 is negative 16. And then minus 1. And so, of course, you're just going to get 12x minus 17. That would be your final answer. Okay, let's do another one. Let's say part D, they're asking you, what is g at f at 6? Just like that. So now we're going to be plugging in the value 6 for x, but it's going into the function of f, which is going into the function of g. So let's recall, g of x is equal to 6x plus 2, and f of x we know is equal to 4x minus 1. So I want to plug in f of x wherever I see x in the g of x equation, right? So I want to plug this into there. So by doing that, I'm going to get 6 times 4x minus 1 plus 2. So what I have written so far here, that's really g at f of x, right? This is equal to g at f of x, because I plugged in f of x into g of x, right? But what I want is g at f at 6, so I have to replace that x with 6. So g at f at 6 would equal this, except I'm plugging in 6 for x. So 6 times 4 times 6 minus 1 plus 2. So 4 times 6 will be 24, minus 1 is 23. 23 times 6 will be 138, and then you'll have 138 plus 2 is 140. So 140 is your final answer. So whenever you see a letter like G and then in the bracket something else, it means you're plugging that thing into the function wherever x is normally. And if the thing inside is another function with another thing that you have to plug in, then you plug that inside that one, right? It's kind of like a function inside a function inside a function. Okay, let's do another example here. Let's say you're given p at t is equal to t squared minus 3t plus 7. And let's say you want to find what's p at 3 equal to. Well, for that, all you would do is you'd plug in 3 for t, so 3 squared minus 3 times 3 plus 7. 3 squared is 9, 3 times 3 is 9, so when you subtract those, they cancel, and you're just left with 7 as your final answer. One final thing I think we should talk about is this other notation, which is a part of function notation, a little bit less common, but you might come across it, so it's good to be prepared. We know what f at g at x is, because we've just done some examples of that. Another way of writing this, no, I don't want you to get confused if you see this, that's why I'm covering it, but another way of writing this is if you have f and then a little circle like that, and then g, then you close the bracket, and then x. These mean the same thing. So a function at a function with that little symbol, and then in a separate bracket, the x, the variable, that means the same thing as this. It means I want to plug g of x into f of x, right? Just like this. So this is important to keep in mind, as you might see that in some examples or maybe on a test or in some homework questions. So just be aware that these mean the exact same thing.